Hello and welcome to our webinar. This presentation will primarily cover anti-stat and anti-fog applications for polyolefin food packaging applications. The presentation provides an understanding of what we do at Palsgaard to design and develop new additive solutions to solve top-of-mind industry concerns, and you're encouraged to make contact with us after the presentation to learn more and find out how we can help you. Here's the agenda for the presentation. I will start out with a short company introduction. I'll look at anti-stat and anti-fog properties and explain how these additives work and show some exemplary results. And at the end, I'll draw up some conclusions to underline how efficient anti-stat and anti-fog additives can support the development of your new innovative packaging solutions. Palsgaard is in its origin a food ingredient company, and we have been in this industry for over 100 years. We've been driven by innovation and a very strong focus on customer interactions. And we pride ourselves that we came up with the first modern food emulsifier in 1917, and that was basically when the company got started in the food ingredient business. And we have since 1925 built application centers around the world. And now, today, we offer more than 100 emulsifier systems to customers around the world for food applications. We've taken that same chemistry and put it into applications outside food, industrial applications, and primarily polymers. And those are the anti-fogs and anti-stats I will talk about today. So this chemistry comes from the food industry, so it guarantees a lot of safety when it's in food packaging and in contact with food. One other important priority in our company is CSR. That's part of our DNA, and we have accomplished to be CO2 neutral for all our factories around the globe last year. And we offer a full product range of RSPO certified emulsifiers and products. From this slide, you'll see that we are a truly global company. We have our main manufacturing facility in Denmark. That's where it all started, in a small town called Juelsminde on the east coast of Jutland in Denmark. And we have expanded throughout the world, and we have manufacturing today in Malaysia, China, Brazil, Mexico. And we also have subsidiaries strategically placed around the world and distribution. So we truly are a global company. All products referenced in this presentation are from the Palsgaard Einar series. And Einar is the name of our original founder of the company, the one who started it all more than 100 years ago. That's his first name, and that's what we've chosen as our brand name for our products. These products are all derived from food ingredient chemistry and optimized for use in polymer applications. The application focus are on anti-stat and anti-fog, mold release, dispersion, lubrication, and processing aids in primarily polypropylene and polyethylene. The Einar products are a perfect match to a sustainability agenda. All products are bio-based and derived from sustainably sourced vegetable oils, which is appealing to many large food companies. Functionality is guaranteed from a broad range of tailor-made products. The understanding of chemistry and functional mechanisms in each application has been instrumental in the development of highly efficient anti-stats and anti-fogs. A competitive market that drives both performance and cost to be constantly optimized, ensure that cost and use is ensured for all our additive recommendations. Packaging materials are constantly undergoing change in order to enhance food product safety, reduce losses, extend expiration dates, and meet new requirements on eco-efficiency and sustainability. When packaging gets lighter with multi-layer structures that are constantly made thinner, it will likely be necessary to modify the use of additives in order to maintain functionality and efficiency. Migratory anti-stats and anti-fogs are a particular concern when thickness is reduced and there are changes of packaging structures, as the migratory properties are highly dependent on polarity, crystallinity, and material thickness. This presentation will deal with these challenges and provide helpful guidelines to challenge and solve many of the problems associated with anti-stat and anti-fog properties in modern packaging solutions. The INA additives are manufactured from vegetable oils, and these raw materials come in many different varieties, mostly distinguished by their fatty acid profiles and various degrees of saturation. Fatty acids can have 0, 1, 2, or more double bonds. The most commonly known products within this chemistry is GMS, glycerol monostearate, and GMO, glycerol monoleate. Both have been used for decades as antistats and antifogs. The chemistry can be made more sophisticated and efficient with polymerization of glycerin to form PGE, polyglycerol esters. PGEs are very efficient antifog and antistat molecules. The polarity of those molecules is changed with the polymerization of glycerin, and the other parameter to work with is the fatty acid profile. The fatty acid will determine how the nonpolar part of the molecule will interact with the polymer. Migration rates, polymer compatibility, and additive morphology on the polymer surface is very dependent on the fatty acid profile. Fatty acids are derived from natural sources and are readily commercially available from C12 lauric acid to C22 behenic acid. In combination, the glycerin and fatty acid building blocks offers many ways to design new additives that fits a certain polarity and a migratory profile. Migration is a necessity. Antistat and antifog additives need to be present at a certain minimal concentration on the polymer surface in order to have any effect. A crucial parameter is therefore the migration rate of the additive. Also of high importance is how the additive interact with ambient moisture and condensed water at the polymer and air interface. Rate of migration is dependent on both the nature of the polymer and physical and chemical properties of the additive. The nature of the polymer matrix will often determine if additives are allowed to migrate. Nonpolar and non-crystalline polymers are ideal. Polyethylene and some polypropylene packaging is therefore ideally suited for migratory additive solutions. For the additive itself, molecular weight, polarity, and stereochemistry will determine migratory properties. These parameters can all be controlled and modified by the glycerin and polyglycerin used and the specific fatty acid profile used to build the molecule. When new chemistry can be optimized with respect to both migration properties and polarity, it provides a unique opportunity to tailor-make highly efficient antistat and antifog additives. Fog formation on plastic films occur when there are specific conditions of humidity and temperature in an enclosed volume of air. Fogging on plastic films is observed when humid air is cooled to a temperature below its dew point. Fog starts forming when the difference between air temperature and dew point is generally less than 2.5 degrees Celsius. In a food packaging application, fogging appears when freshly packaged food is placed in refrigerated storage. This is, for example, the case with packaged meat, oven-baked products, vegetables, salads, and fruits. Antifogs will reduce the surface tension of the polymer and air interface to a point where the surface energy of the polymer is equal to the surface tension of water. This will make condensed water settle as a thin continuous film and not as small discrete droplets. Palsgaard has recommendations for a broad range of applications in both polypropylene and polyethylene. And here you see an overview of our recommendations for polypropylene and polyethylene, both antistat and antifogs. The antifogs that we'll focus on in this presentation are INA 618, that is for polypropylene film, and INA 611, that is a polyethylene antifog. It is necessary to control condensation of water in packaged food. It is unacceptable for a number of reasons. It reduces the visibility of the product and provides a less attractive appearance of the packaged food. And also, quality appears less attractive to consumers when there's condensation of water on the packaging. Presence of water droplets and accumulation of small pockets of water can deteriorate products and reduce shelf life. Here we see results from a polyethylene film where we are recommending INA 611 as an efficient antifog. Antifog performance is a visual rating of film clarity. The antifog property is rated A through E, from 0 visibility, where the film is covered by water droplets, to the completely transparent film, where water is spread as a thin continuous layer on the polymer surface. Migratory anti-fogs work well in many different PE applications. It can be challenging to reach excellent performance in some cold-extruded and laminated films. Depending on polymers used, film thickness, and if there's a lamination process involved, reaching the level of performance needed can be a very challenging task. Polydiscal esters like our INA 611 is developed to perform under challenging conditions, and results will often look like the ones shown here. This is a cold product performance in a PE film. INA 611 is ideally suited for cold-extruded and laminated packaging films, where the anti-fog is often added to a very thin section of the entire film. It has a fast response and will remain efficient long-term. Illustrated here by very good ratings 18 months after film has been manufactured. Often, very little disturbance can tip results out of the required performance window. Here illustrated by results from competing PGE chemistry that may work well in a conventional PE packaging, but when challenged, results start to fall behind. When we turn to polypropylene, we'll see a different picture. Polypropylene is significantly more challenging than anti-fog in polyethylene. You'll see from these data that results are overall good, but it's not easy, sometimes bordering impossible, to obtain the very high consistency and efficiency often seen in a typical PE application. Additive concentrations are much higher, where we can use 0.2 to 0.5, 0.6% in polyethylene. In polypropylene, that will be 1.5 to 2%. Here results seen here for the INA 618, we are at 1.5%. And the reason for it is not because the polarity of the molecule has changed, it's simply because polypropylene is a polymer with higher crystallinity, and as these additives migrate in the amorphous phase, it's much more difficult to migrate in a polypropylene polymer, and therefore to get the necessary amount of additive on the surface, you will need more additive, higher loadings in the polymer to achieve your result. And even then, it becomes challenging on the surface, as results are indicating. They are pretty good for a polypropylene film here with INA 618, but they're not as consistent and high performing as if it was a polyethylene film. And here on the right side, we have a traditional crystal ester, where it's very, very difficult to obtain any kind of performance that will be acceptable in a polypropylene film. That's a big difference between polyethylene and polypropylene. Polyethylene anti-fogs, they can only work good, and even structures, when they get complicated, you can make it work really well if you choose the right chemistry. Polypropylene, it's more crucial also to look at the high end of the scale in terms of chemistries that you put into those kind of applications, because that is a very, very challenging task to obtain good anti-fog performance. Anti-stats are similar to anti-fogs. They have the same working mechanism, but they typically have a different interaction with water or moisture. Therefore, the chemistry is not the same. They are slightly changed, and overall, if you look at what's being used in anti-fog applications compared to what's used in anti-stat applications, then anti-fogs have higher compatibility with water in general. They are lower melting products, and often anti-stats, they're higher melting, and they'll be solids. They can come in pellet and powder form, whereas anti-fogs are often delivered as liquids or in paste form. So here again, we have the overview of our products that we recommend for polyethylene and polypropylene. And the anti-stats that we're going to focus on in this presentation is the INA 411, that is an anti-stat for polypropylene film, and INA 601 that we recommend for a variety of different polyethylene film applications. An anti-stat property is often incorporated into a polymer by adding small amounts of migratory anti-stat. After injection molding or film extrusion, the anti-stat will migrate to the packaging surface and build a sufficient concentration to form a layer that can bind ambient moisture and thereby form a conductive layer. This will enable dissipation of static charges, so dust and other fine particles will not settle on the packaging. Anti-stat protection is needed in many different packaging applications. They are used to prevent dust attraction to packaging where an attractive appearance toward the consumer is important. Anti-stats are also vital in securing smooth and uninterrupted operation on high-speed packaging lines. When powdered products are packaged, efficient anti-stat protection will prevent that product fines are not contaminating the heat seal area. Mold release and denesting properties are often referred to as belonging to the same family of functionality, especially true for PP injection molding applications, where the anti-stat added serves several different purposes. When an anti-stat concentration is present, it will also function as a mold release. And for final stacked items, it will modify coefficient of friction and provides the needed denesting properties. In this example, we show our INA 411 that is recommended as an anti-stat for polypropylene film. Anti-stat properties are measured as static decay time. The method measures the ability of a grounded material to dissipate a known charge. We charge to 5,000 volts and measure the time it takes to reach 500 volts. Time is measured in seconds, and numbers below 2 seconds indicate very good performance, and below 1 second, performance is rated excellent. We are comparing to a very well-known and used combination anti-stat-wise in polypropylene, and that's ethoxylated amine and GMS. We are seeing that some of those chemistry that traditionally has been used as anti-stats in many different food packaging applications are changing, and there's an increased focus on not using the ethoxylated amine chemistry due to safety, and so it's questioned whether it's a good idea to use those kind of materials that migrate to the surface and potentially can migrate into food. Results show better initial performance of INA 411, and the alternatives are also looking pretty good long term. Results here are clearly confirming that a replacement of ethoxylated amine is possible. Results do not necessarily need to show superior performance in order for replacement to take place, but as good as a performance as you would obtain with an ethoxylated amine solution is good enough. At equal loading levels, there will be a cost and use benefit when switching from ethoxylated amine to INA 411, adding to the benefits of going amine-free. On this slide, we're showing results for our INA 601 in polyethylene film. INA 601 is a highly efficient anti-stat that will work really, really well at low loading levels in many different polyethylene film applications. And here we're showing again that ethoxylated amine anti-stats can be replaced efficiently by chemistry that is glycerol ester based and generally regarded as a chemistry with high safety that is unquestionable, as it's also used as additives directly added to food. INA 601 offers excellent performance in a very broad range of PE applications. Results shown is for a 30 micron blown low density polyethylene film. And our INA 601 is shown here to really outperform the ethoxylated amine and GMS combination, both short term and long term. In co-extruded and laminated packaging films, the anti-stat is often added to a very thin section of the entire film, and therefore the anti-stat must be a very reliable and efficient performer. INA 601 will deliver the performance you need, and it has also shown to work well in linear low-density polyethylene film, metallocene linear low-density polyethylene film, and high-density polyethylene. In this slide, we are showing not anti-stat performance, but a similar type of an application that is often referred to as anti-stat. It's mold release. And injection molding applications, a mold release is a very commonly added additive. It helps deforming the item from the mold. And what is often used here is distilled glycerol monostearate. And what we're showing here is that there is an advantage of using the high purity version of glycerol monostearate, which is our INA 201, over the lower purity GMS 60 or even GMS 40. That here you can see that with the higher numbers, you get better performance, a higher reduction in mold release force. So therefore, in comparison, you need lower addition of additive if you use the higher purity version of the GMS. And we're also showing a comparative example to erucimide that is also often used as a mold release. And again, here, a high purity GMS is a very, very efficient additive to create mold release in an injection molding application. And another thing that is also gained from adding these mold release additives is a denesting property. So these properties are necessary when stacking items and you want to separate them again on a packaging line, that you will have to reduce the coefficient so there's no stickiness between injection molded items. So you can easily take one item at a time with a robot on a packaging line. The products and solutions we are offering are based on knowledge and data generated in dedicated laboratory facilities at the Palsgaard main location by Juelsminde in Denmark. We have a complete lab extrusion setup to manufacture both blown and calendar film. There are injection molding capabilities to produce specimens for testing anti-stat properties. We can do mold release and mechanical testing of injection molded dumbbells. We also have compounding and master batch production for lab scale testing. The lab is equipped to measure anti-stat and anti-fog properties, coefficient of friction, mechanical properties, and other relevant testing in order to fully assess and understand how our products work in the different polymer applications. Efficiency and cost in use are key design parameters for the incorporation of anti-stat and anti-fog properties in a packaging solution. But so are sustainability and a concern for anything that can produce bad press on a particular product. Any risk that can compromise safety is high priority at a brand owner and should be eliminated. There is increased focus on the chemistry and safety profile of additives when there is a chance that these products, albeit in small amounts, can end up in a food product through migration from a packaging material. Dual-use additives that are added both directly to food and in the packaging material itself represents the ultimate safety. The Palsgaard INA products range fits the agenda perfectly with tailor-made and highly efficient solutions, and at the same time, they meet the highest possible safety standards with their background in vegetable-based food additive chemistry. Excellent and ever-improving performance of anti-stat and anti-fog additives will also support the food waste agenda. With better performance of additives follows extended shelf life of packaged food. An improved appearance will also reduce deselection at the consumer level so that turnover is higher, leading to a reduction in products that will run past the best before date on the supermarket shelf. With testing facilities and extended product knowledge, Palsgaard has the ability to help design and develop new and innovative solutions. We are here to help and are looking forward to work with you in the future. Thank you for listening to this presentation. If you would like to know more on how we can help and what Palsgaard has to offer, then please call or email. Additional information is available from our website at polymers.palsgaard.com. Thank you.